Imagine our universe is just one of countless others, each with its own set of physical laws and properties. Sounds like a sci-fi movie, right? But this isn't a Hollywood blockbuster, it's the intriguing concept of the multiverse, a theory that has captured the imaginations of physicists and philosophers alike. The multiverse theory is like thinking of our universe as a bubble in a cosmic ocean, surrounded by an infinite number of other bubbles or universes, each unique in its own way. Now, these aren't bubbles you could pop with a pin. Each universe could be vast, possibly even infinite, varying in size and shape and governed by its own set of physical laws. Some could be just like ours, while others could be so strange and different that they defy our current understanding of physics. Now here's where it gets even more mind-boggling. Some versions of the multiverse theory suggest that these universes aren't static. Instead, they propose that new universes are constantly being created in a cosmic bubble bath of sorts. Imagine that. New universes bursting into existence even as we speak. On the other hand, some theories propose that these universes aren't isolated from each other. They could collide, merge, or even interact in ways we can't yet comprehend. The results of such interactions? Well, that's a mystery we are yet to unravel. So the next time you look up at the night sky, remember, the stars you see could just be a tiny fraction of a much larger, possibly infinite multiverse. It's a humbling thought, isn't it? And here's a thought to really get your neurons firing. If there are indeed multiple universes, each with its own set of physical laws and properties, could there be another you living in a parallel universe? A fascinating thought, isn't it? What if our entire universe is nothing more than a sophisticated computer program? This provocative question leads us into our second theory, the simulation hypothesis. This concept, as mind-bending as it sounds, proposes that our reality might not be as real as we perceive it to be. Now imagine the complexity of our favorite video games. They can create entire worlds, complete with physics, weather systems, and artificial intelligence. Now take that concept and amplify it to an unimaginable scale. The simulation hypothesis suggests that our universe, with its galaxies, stars, planets, and even us, could be a product of a super-advanced computer simulation. But who could be behind such an intricate deception? The architects of our reality, according to this theory, could be advanced beings from a higher level of reality, or perhaps even future humans with unfathomable technological prowess. These entities, whoever they might be, could have designed our universe for reasons beyond our comprehension. Technology has played a significant role in giving the simulation hypothesis some credibility. As our computational abilities have advanced, so has the complexity of our simulations. We've gone from pixelated 2D worlds to immersive virtual realities in a few decades. Extrapolating this progress into the far future, it seems plausible that a civilization could eventually simulate an entire universe. However, the simulation hypothesis raises profound philosophical and existential questions. If we are living in a simulation, what does that say about free will? Are our thoughts and emotions merely predetermined responses coded into us by our simulators? And perhaps most intriguingly, could we ever break out of the simulation or communicate with our creators? The simulation hypothesis is truly a rabbit hole of speculation and wonder. It pushes us to question the very nature of reality, an inquiry that has been at the heart of philosophy and science for centuries. Are we merely lines of code in a cosmic algorithm? The simulation hypothesis certainly gives us food for thought. As we explore the cosmos and our place within it, we must be prepared to challenge our assumptions and embrace the unknown. We perceive the world in 3 spatial dimensions and time, but what if there are more? This question takes us to our third theory, the concept of higher dimensions. This proposal invites us to consider that our daily reality of length, width, height, and time might just be the tip of the cosmic iceberg. The notion of higher dimensions is not a new one. It's rooted in the complex field of string theory, which postulates that the fundamental constituents of reality are tiny, vibrating strings of energy. Intriguingly, for the mathematics of string theory to work out, there need to be additional dimensions, as many as 7 more. But where are these extra dimensions hiding? The answer might lie in the concept of compactification. This theory suggests that the extra dimensions could be so incredibly tiny and tightly curled up on themselves that they're practically invisible to our senses. Like a garden hose viewed from afar appears as a line, these dimensions may be too minute for us to perceive directly. So if these dimensions are so well hidden, how do they affect our universe? Well, they could be the key to solving some of the most perplexing puzzles in cosmology. For instance, the elusive dark matter and dark energy, which make up about 95% of the universe, yet remain invisible to us. These phenomena could be the result of gravity or other forces seeping into our three-dimensional world from these hidden dimensions. Moreover, the existence of higher dimensions could also offer insights into the Big Bang, the birth of our universe. They might help to explain why the universe expanded so rapidly in its earliest moments, a phenomenon known as cosmic inflation. The possibility of higher dimensions certainly adds a new layer of complexity to our understanding of the universe. While we can't directly experience these dimensions, their potential existence challenges our perception of reality and invites us to view the universe in a whole new light. Visualize giant bubbles floating in an endless cosmic ocean. Could our universe be just one of these bubbles? Let's delve into the mesmerizing concept of cosmic bubble collisions. This theory presents the idea that our universe may be akin to a bubble, floating amidst countless others in a vast cosmic sea. Each of these bubbles represents a separate pocket of space-time, encapsulating its own unique set of properties. Just like bubbles in a champagne flute, these cosmic bubbles might drift towards each other, eventually colliding or merging. This isn't your everyday fender bender though. We're talking about a collision on an astronomical scale, capable of reshaping the fundamental fabric of reality. The effects of such an event are hard to fathom. It could lead to the birth of new universes, the alteration of physical laws, or perhaps even the end of a universe. The outcomes are as varied as they are mind-boggling. This theory is a bit like a cosmic detective story. The clues are subtle, and the evidence is scarce. Detecting a cosmic bubble collision would require us to observe imprints or scars in the cosmic microwave background radiation, the afterglow of the Big Bang. These imprints could be the remnants of an ancient bubble collision etched into the fabric of our universe. However, despite our best efforts, and the most sophisticated telescopes, we have yet to find any direct evidence of such collisions. This doesn't mean the theory is wrong though. It simply highlights the vastness of our universe and the limits of our current observational capabilities. It's worth noting that the theory of cosmic bubble collisions is one of many, each offering its own perspective on what lies beyond our observable universe. These theories are not mutually exclusive. They could all be facets of an even grander cosmic truth, waiting to be discovered. While we haven't observed any evidence of such collisions, they remain a tantalizing possibility. The cosmic conundrum continues, inviting us to question, explore, and marvel at the mysteries of the universe. What if beyond the observable universe lies something entirely beyond our comprehension? This thought-provoking question takes us into the realm of the fifth theory we're exploring today, the idea that regions of space-time may exist where our laws of physics simply don't apply. Our current understanding of physics is a product of the observable universe, a realm governed by the laws of nature as we know them. But what if there are regions where these laws break down? We've seen glimpses of this in the extreme conditions of the early universe, where the laws of physics as we know them were not in effect. The same is true for black holes, where gravity becomes so strong that it warps space-time, creating a singularity where our current understanding of physics ceases to be adequate. Now imagine that beyond the observable universe, there are regions with conditions so extreme, so alien, that they are governed by a completely different set of physical laws. Or perhaps there are areas where the concept of physical laws as we understand them doesn't even apply. These regions could be home to phenomena so exotic, so beyond our current comprehension, that they challenge our very notion of what it means to exist within a universe. This is not just a wild speculation. Some of the leading theories in physics, such as string theory and quantum gravity, suggest the possibility of such exotic realms. These theories are still in their infancy and much work remains to be done, but they open up a whole new world of possibilities about the nature of reality beyond our observable universe. The question of what lies beyond the observable universe is one of the most intriguing mysteries facing humanity. We may never find a definitive answer, and that's okay. After all, science is not just about finding answers, but about asking questions and embracing the unknown. The journey of discovery is a thrilling adventure in itself, and who knows what astonishing revelations await us as we continue to explore the cosmos.